Hello everyone and welcome you all once again to Maths by Gurpreet Sekhon. So far we have been discussing the differentiability, that is 12th classes 5th chapter, and we have successfully done our concepts till the equations of parametric functions and how to differentiate them. So today we are going to start with our next exercise, in which the main topic is second order derivative, as I have already written. So without wasting even a second, let's start with our today's topic. Second order derivative. It's very much clear from the heading itself that we are talking about something which we have to repeat or which we have to do secondly as well. Firstly, consider a function y as a function of x. Any function y which is a function of x, differentiate it once, that is we get dy upon dx, and the function gets differentiated and we get f of dash x. F of dash x means single derivation. Then again differentiate y with respect to x, again differentiate the same function. On the right hand side you will get f of double dash x, because double differentiation, and d upon dx differentiates dy upon dx, and you will get d2y upon dx square is equals to f double dash x. This is known as second order derivative, and we can also call it as d square as well. So in this exercise we only have to find the second order derivatives of functions that will be given in the examples. So you have to do nothing, just firstly differentiate the function once, then your answer, get that answer, and then differentiate that answer again with respect to x. So that is all what we have to do in the exercise. Let's start with our very first example, that is example 38. We have to find the second order derivative, that is d2y upon dx square, and it's given y is equals to x cube plus tan x. This is our function. All right, now let's differentiate this. We have to find the double differentiation. So firstly, what is our y? That is x cube plus tan x. Firstly find dy upon dx. Differentiation is very simple. X cube, so firstly we'll write d dx of x cube and just split the differential, then d dx of tan x. So let's differentiate it. X cube differentiation, we'll get 3x square, and what's the differentiation of tan x? That is secant square x. Clear? We have differentiated the given function one time, but we have to find the second order derivative. Clear? So we'll differentiate it again. Let's do that. d2y upon dx square, what does it mean? That we have to differentiate it again with respect to x, 3x square plus secant square x. Clear? What will be the differentiation of 3x square? 2 will be written before 3 and it will be multiplied by 3, and you will get 6x. Then secant square x, 2 will be written before secant, 2 of secant x, then secant will be again differentiated. And what's the differentiation of secant x? That is secant x tan x. Clear? So you will get, just simplified a bit, 6x plus 2 secant square x tan x. So this is our required answer. This is how we differentiate a single function two times, and it's known as the second order derivative. With this we are done with our 38th example, which was a very simple one. Let's start with our next example, that is example 39th. The given function is a sine x plus b cos x, and it's automatically understood that a and b are constants here. We have to prove d2y upon dx square plus y equal to 0. So firstly we'll find the value of d2y plus dx square, then we'll add it into y, then we'll find that if it's coming out to be 0, it has to be 0, okay, because we have to prove this thing. Firstly we'll find this thing, so differentiate it once, dy upon dx. You will get a is constant. What's the differentiation of sine x? That is cos x. And what's the differentiation of cos x? B will remain as it is. Cos x differentiation is minus of sine x. Clear? Now a of cos x will remain as it is. We'll get minus b of sine x. This is differentiation of the given function once. Now again differentiate it with respect to x. You will get a, and what's the differentiation of cos x? That is minus sin x, minus b. What's the differentiation of sin x? That is cos x. So your equation will be minus a sin x minus b cos x. This is the value of d2y upon dx square. Clear? So firstly, write the left hand side of the given equation. What's it? Left hand side is d2y upon dx square plus y. So what will it be equal to? It will be equal to minus a sin x minus b cos x. Fill in the value of d2y by dx square. We have filled it. Then plus, what's the value of y? That is a sin x plus b cos x. It's pretty much clear from here that this is of opposite sign, this is of opposite sign, and these two are also of opposite sign. So as a result, we'll get 0. And what is 0? That is our right hand side. So in this way, we can prove the given equations in which the requirement was of a second order derivative, and we found that second order derivative, then we added y in it, and as a result, we got 0. So you can see how easy this is. Only you have to take care of the signs of the functions that you are differentiating. Because if, for example, a student make mistake that plus of b cos x, then he or she will never get 0 as the answer. So that is why you have to take care of the signs that are going to come before the functions that you are differentiating. So we're done with example 39th. Let's move to the 40th example. In the 40th example, the function that is to be differentiated is 3 e raised to power 2x plus 2 e raised to power 3x. We have to prove an equation just similar to the previous example. In this equation, we have to find the second order derivative, then the multiplication of 5 and the first order derivative, and the product of 6 and our given function. And we have to prove that this whole equation gives 0 as the answer. Firstly, what's y this? And we'll find the single order derivative, the first derivative, that is dy upon dx, and we can find it very easily. What is it? 3 is constant. What's the differentiation of e raised to power 2x? E raised to power 2x, and 2x will be again differentiated, and you will get 2. Similarly with the second term, 2 is constant. What's the differentiation of e raised to power 3x? E raised to power 3x, and when 3x will again be differentiated, you will get 3. So 2 3s are 6 e raised to power 2x plus 6 e raised to power 3x. This is your first derivative, and you can take 6 as a common factor. E raised to power 2x plus e raised to power 3x. Clear? Now, let's start with the solution of second order derivative, d2y upon dx squared. 6 is constant, it will remain outside only. When e raised to power 2x will be differentiated, you will get e raised to power 2x multiplied by 2. Then plus e raised to power 3x. When 3x will again be differentiated, you will get 3. It's a very basic technique of exponential differentiation, which I have explained in my previous video. So if you haven't watched those videos, kindly go and watch them in order to explain the basic differentiation of exponential terms. So 6, then 2 e raised to power 2x plus 3 e raised to power 3x. Clear? So we have got our first order derivative and second order derivative as well. So now put it in the left hand side of the given equation. What is the left hand side? That is d2y upon dx square minus 5 of dy upon dx plus of 6y. Now fill in the values. What is the value of d2y upon dx square? That is 6. 2 e raised to power 2x plus 3 e raised to power 3x. Then we have to multiply 5 by our first derivative. So 5 6 is 30. Minus of 30 was the value e raised to power 2x plus e raised to power 3x. And then plus 6 of y. What is y? 3 e raised to power 2x plus 2 e raised to power 3x. Just open the brackets. 6 2s are 12 e raised to power 2x. Plus 6 3s are 18 e raised to power 3x minus 30 e raised to power 2x minus 30 e raised to power 3x plus 18 e raised to power 2x plus 12 e raised to power 3x. Clear? We have only multiplied the constants. So 12 e raised to power 2x plus 18 e raised to power 2x, that is 30 e raised to power 2x minus 30 raised to power 2x, you will get 0. Then 18 plus 12, again 30, 30 minus 30, 0. So as a result, you will get 0 as your answer, which is equal to your right hand side. So in this way, you can solve the given equations by just substituting the values that are required in the equation. Either it's first order derivative or second order derivative. You can do that. Let's move to our next example. Example 41. Given function is sine inverse x. Then again we have to prove that 1 minus x square and the second order derivative minus x and the first derivative is equal to 0. Firstly, we'll do nothing. We'll only solve it by finding the second order derivative first. So we'll find firstly dy upon dx. Now what's the differentiation of sine inverse x? That is 1 upon under root 1 minus x square. Clear? Now we are done with this dy upon dx. We have to find d2y upon dx square. d2y upon dx square. Now it's a very tricky equation because there are a lot of methods to solve this. Some students apply u upon v formula, but I personally believe that it's more easy to solve by this method. Now take it in the numerator, so you will get 1 minus x square raised to power minus 1 by 2. Clear? Now we have to differentiate this. The power in the denominator was 1 by 2, and when you will take it to the numerator, you will get minus 1 by 2. Now just differentiate it simply as you differentiate other functions. Minus 1 by 2 will come before the bracket, then 1 minus x square, then we subtract 1 from the power, that is minus 1 by 2 minus 1. And 1 minus x square, the differentiation of that will happen again. So 1 minus x square, the differentiation of 1 is 0, minus x square minus 2x. So it will be minus 2x. We will get this. Now just we have to solve the power only. So 2 and 2 will be cancelled and minus will convert into plus. So you will get x multiply 1 minus x square, and minus 1 by 2 minus 1 is minus of 3 by 2. Now the power is in minus, so just simplify it a bit. X will be divided by 1 minus x square raised to power positive 3 by 2, because it's again shifted to the denominator and the sign of power will again be changed. Now x upon 1 minus x square power 3 by 2. Now firstly just substitute in the equation, then I'll tell you what we'll do to simplify it more. Now what's our left hand side? That is 1 minus x square. Now fill in the value of d2y upon dx square, which is this, x upon 1 minus x square raised to power 3 by 2, then minus x multiplied by dy upon dx, that was 1 upon under root 1 minus x square. Alright, so now we have x here and x here, but we demand under root 1 minus x square in the denominator in order to subtract the both of the terms and then to get 0 as the answer. So just split the power of this thing and you will get 1 minus x square as an individual bracket. You will get 1 minus x square x, and 3 by 2 can be splitted into 1 by 2 plus 1. So root 1 minus x square will be separated and one bracket of 1 minus x square will be remained only, and then subtraction x upon under root 1 minus x square will be there only. So now its power is 1 by 2, its power is 1. So when the powers will add, it will again add up to 3 by 2. So we are not doing anything wrong and we are not introducing anything from ourselves. It's just we have splitted the power. Now 1 minus x square will be cancelled. You will get x upon under root 1 minus x square minus x upon under root 1 minus x square. And you will get a 0 in the answer, which will be equal to right hand side. With this example, we are done with all of the examples of this method, that was second order derivative, and it's pretty much easy. I hope you have also found this method very easy, and now I'm sure that you can attempt all of the sums related with this method in the exercise. Still, if you find any doubt in any of the sum, don't forget to just post your queries in the comment section, and before leaving my channel, do press the subscribe button and the bell icon to get new updates regarding new exercises on the daily basis. So keep practicing with the mathematics subjects and good luck.